awesome world we inhabit. Today we use the resources from prehistoric times to build the future. Just as volcanic eruptions shape our planet, the right technologies can reshape how industries operate safely in hazardous environments. And steute Technologies is driving innovation to shape just that. They've released a line of interlock switches for use in explosive zones. Interlocks ensure operator and machine safety by preventing equipment operation unless guarding is secure. One such capability is to monitor door positions in automated cells. The switch uses locking mechanisms and dual-channel signals to verify closure. If contacts fail, the system halts, ensuring safe entry. However, in explosive zones, preventing system failures is tough because elements like dust, moisture, and corrosive substances can damage the components. Electrical shorts and jam locking mechanisms can disrupt proper operation. Over time, proper sealing or wear increases the risk, potentially allowing equipment to power on unsafely, putting both operators and the environment at risk. Explosion zones are not zones you want to be trapped in. So how has steute Technologies enhanced safety? We'll let you know coming up, but first, it's our premier product highlight, sponsored by Mauser Electronics. Siemens SIRIUS 2 contactors deliver high contact reliability, durability, and performance in extreme conditions. Featuring the 3RT series, these contactors handle up to 2,650 amp switching without current derating. S2 contactors offer 690 volt insulation, 6 kilovolt surge resistance, and a mechanical lifespan of up to 10 million cycles. It features auxiliary switches, 6.6 watt power loss, and shock resistance. Designed for industrial applications, they comply with all major standards and certifications, ensuring global usability and reliability. Check out the Siemens SIRIUS 2 contactors today by visiting Mauser.com or by clicking the link in the description. When we gain knowledge, we gain possibilities, which is why we present David's Corner.
Thanks, Andy. For a while now, having worked with PLCs, I've always wondered, well, if the PLC is just a really simple computer that's stuck inside of a case that we can add different modules to get information about our surroundings and send output instructions, then why not just make that computer a little bit more complicated and add some of the features and functionalities that we already find on modern computers and let that control our system? Well, that's exactly the idea behind the industrial PC, or the IPC. Now, an IPC really is just a computer that contains all of the standard pieces that we'd see inside of a computer: the motherboard, the memory, connection ports for Ethernet, USB ports, HDMI, USB, sometimes even wireless connections. But the thing that sets them apart from regular PCs comes in two different ways. First of all, they're built inside these cases that are very rugged. That means that they can withstand the industrial environments way better than your laptop or a tower PC typically would be able to. The second thing that sets them apart is that a lot of the communication protocols that are enabled into it by default are attached on industrial connectors, and they follow protocols like RS-232 or RS-485, which are capable of communicating with all the devices around an industrial facility. Now, there are many people who've created that ability inside normal computers, like on their standard laptop or tower computer, but those ones often aren't durable enough and they're not well understood enough to be able to be troubleshot by other engineers who come along after. So these custom solutions are usually not the best ones for an industrial environment. But now, thanks to these industrial PCs, we have many more connection abilities with I/O ports that are removable, sometimes even the familiar modular connections that we see on PLCs, but they contain a full operating system that allows computer engineers to write programs that can not only communicate with our I/O devices, but also to be able to communicate with networked peripherals, do much more custom algorithms, even machine vision or AI inside the computer, which we're seeing more and more of these days. In addition to that, with the ability to connect to a network in a much more secure fashion, then these can become the gateway that allow your information on your field level to communicate with a cloud or edge system in a way that normally would be very risky to connect a PLC to be able to do. So really, the computer technology is just the next evolution of the industrial controller. But as that migrates and advances, we have many things to consider, like how well are engineers going to understand this and troubleshoot problems? How secure is it going to be in an industrial setting? So we do have some challenges to overcome, but these industrial PCs are designed to overcome those challenges and give engineers a better platform to be able to create these customized solutions to the problems that are continuing to get more complex as the days go by. Andy, back to you.
Danger zones have evolved significantly for humans, yet in industrial settings, mammoths aren't generally a concern. A failed interlock, however, can be a critical matter, as it can expose workers to serious risks such as injury, entanglement, or hazardous substances. And the environment can suffer as well. Some potential failures may result in chemical leaks, fires, explosions, or long-term contamination. Well, to help reduce these harms, steute Technologies has designed the STM 515 Extreme. The STM 515 is a robust solenoid interlock built for harsh conditions. With an IP66-67 rated corrosion-resistant enclosure and protected wiring, it ensures durability. It's also available in spring-to-lock or power-to-lock configurations tailored to specific applications. The interlock features an escape release facing the danger zone, allowing users to override it if someone is trapped inside. It contains two sets of contacts, one for the actuator and another to monitor the lock, providing dual-channel feedback to ensure the interlock is securely closed and locked. Our world is a dangerous place, but engineers have been at the forefront for making it a little less so, which of course includes the spear.